Hey everyone, welcome to today's Explainer. I am absolutely thrilled to be here with you because, well, today we are going to look at programming through a completely different lens. We're tackling one of the absolute core concepts in Python, the constructor. But we aren't just going to stare at lines of code. Nope. Instead, we're going to look at software development through the eyes of an architect. Because when you're writing code, you are quite literally building structures. And the best part, as software architects, we don't even have to wear hard hats or worry about the rain ruining our site. Every great structure needs a rock-solid start, so get ready because we're about to learn how to build magnificent, structurally sound Python objects right from the ground up.
Okay, let's dive right into this. How does Python actually build things from scratch? When you're coding, you aren't just typing characters into a blank text file. You are conceptualizing complex, interactive entities. You're creating user profiles, processing data streams, or maybe even building enemies for a video game. But how do these complex objects actually come into existence in your computer's memory? How do we go from a completely empty lot to a fully functional entity ready to do exactly what we tell it to? That journey of creation is exactly what we are going to unpack today.
Section 1. Blueprints and Buildings.
To really wrap our heads around this, I want you to step out of your code editor for a second. Imagine you're the lead architect on a massive new city development project. The blueprint represents a Python class. It's like typing class user in your script. It dictates exactly where the walls go, how many doors there are, and the layout of the plumbing. It is a perfect abstract design. But you can't live in a blueprint, right? You can't open its paper doors or turn on its drawn-in lights. The building, on the other hand, represents a Python object. This is the physical home. It has real materials, it takes up physical space, and it's built perfectly on the instructions of the blueprint. In Python, your class defines the structure, but the object is the actual tangible data living in your computer's memory.
Section 2. The Python Constructor.
So, the real puzzle here is figuring out the transition. How do we actually bridge the gap between that paper blueprint and the livable building? What's the mechanism that takes our theoretical design and turns it into a physical reality? Well, we use a constructor. A constructor is the specific method that initializes an object's foundational state. Think of the constructor not as the blueprint and not as the finished house, but as the actual construction crew. They're the ones who roll up to the empty lot, read the blueprint, and start pouring the concrete foundation. They set up the basic scaffolding so that everything else can safely be built on top. And as you can probably guess, without this absolutely crucial step of initializing the foundation, any structure you try to build is just going to collapse.
Now, in Python, that construction crew has a very specific name. It's init, surrounded by double underscores on both sides. In the coding community, you're often going to hear this affectionately called dunder init, which is just short for double underscore init. Fun little fact here, Python uses these double underscores for special under-the-hood background methods so you don't accidentally name one of your own regular functions init and just break the whole system. It's pretty smart. Whenever you see this specific method inside a Python class, you instantly know you're looking at the exact instructions for pouring the foundation of your new object. It's basically the universal signal to Python saying, hey, when you build this thing, start right here.
Section 3. Laying the foundation.
So we know what the blueprint is, we know what the finished building is, and we've officially met our construction crew. Now let's look at the mechanics of creation. What literally happens behind the scenes when you tell Python to start building? Well, step 1, you call the class, like typing user with parentheses in your code. This is you handing the blueprint over to the general contractor and saying, build this. Step 2, Python automatically triggers the constructor. That dunder init method leaps into action, the concrete is poured, and the foundational data is locked right into place. And finally, step 3, Python returns the object. The keys to the finished building are handed back to you, and the object is now fully formed, residing safely in memory, and ready for you to use in your program. And this brilliantly illustrates that seamless flow from a simple idea to a totally usable object.
Section 4. Why constructors matter.
It's one thing to know how a constructor works under the hood, but why is setting this foundation so critical for writing clean, professional code? Let's quickly run through the core responsibilities of your dunder init method. First up, assigning initial values. If you're building a user object, the constructor makes sure they have a name and an email address the literal second they are created. Second, setting up variables. In Python, this is where you use the self keyword to attach data directly to that specific building, making sure you reserve the necessary space in memory for the object's unique data. And finally, preparing the object for use. By funneling all this essential setup through the constructor, you guarantee that every single new building you create is safe, stable, and completely ready right out of the gate. You never have to worry about an object missing its crucial parts because the constructor ensures the foundation is perfect, every single time.
Which brings us to our final thought for today's explainer. We've explored the abstract blueprints, we've met the hardworking construction crew, and we understand the vital importance of pouring a solid foundation using Python's dunder init method. The actual mechanics of creation are now entirely in your hands, so I leave you with this question. Now that your foundation is poured, what will your Python objects build? Honestly, the sky's the limit. Thank you so much for joining me to explore the architecture of Python. Keep building, keep coding, and I'll see you in the next explainer.